Thought I'd bust out one of these ones here where we figure out, I give you an elevation, right? The formative assessment has, let's look at it, let's examine it at a particular time and at a particular horizontal distance. But it didn't have the elevation, so it's not terribly hard, but I'm going to do it anyway. Because somebody might have a question about that, right? So let's see. In the previous problem, we got that these components were, here, let's draw a picture here. Here it is, right? We're shooting it at a nice high angle of 55.4 at 31 meters per second. Right, and it's going to go, presumably it's going to go higher than 30 meters elevation, or this is not a silly question, right? And so we want to know what's its velocity in and the position of the ball, right, in proper component vector notation, right? So this, let's see, so when I did this, right, of course, remember that, our x component and our y component, our initial, right, these are just from sine and cosine, right? So cos of 55.4, right? And then this guy is 31 sine 55.4, the y component, right? And those worked out to 17.603 and 25.517. Okay, so those are our initial velocities. Let's, RSTLNE, right? This guy is negative 9.81. Okay, and then what else do we know? Oh, this guy is 17.603. Any horizontal velocity anywhere examined is always that because we're ignoring air friction, right? Okay, so let's see, 30 meters on the way up. I'm going to use this. That's my displacement vertically, right? 30.0. And now this is solvable. We got boom, boom, and Betty boop, right? So let's solve for the final velocity. Okay, so v is the square root of 25.517 plus 2 times negative 9.81 times 30.0 apparently, right? Okay, so this, by the way, is my variable b. Let's just make sure, yes it is. So I'm going square root, left parenthesis, because I've got a very old calculator. And then I go alpha b squared plus 2 times negative 9.81. Don't forget to make your 9.81 negative and your 30 positive. Okay, and we should get a number smaller than this. It should have a less vertical velocity. And indeed, I get 7.9, I'll say 7.908 just for kicks. 7.90, actually it's 9075. If you follow my OCD of carrying all these 5 digits, right? I'm going to, by the way, store that just for kicks in V, because that's what it is. Okay, now, notice that we've got to choose. It's 7.9075. We've got to choose because this is an absolute value here, right? We have to choose whether it's going up or whether it's going down. Okay, so now we look over here and it's asking us for on the way up, right? So therefore we choose the positive. Always be mindful of that, right? Whenever you use this formula, think about it. Just don't always use the positive. In this case, we're using the positive because it's asking for it on the way up. The next part here, I think I asked another one where it's on the way down. We're going to put it right there, and it'll be negative. Okay. Now I'm set. Now I can find my time. I'm going to use v equals u plus at. So 25.517 equals positive 7.9075 plus negative 9.81 times little bitty t. Okay, there we go. So that guy, hold on here. So I'm going to go boop. Let's see. Okay. And then divided by 1.795. 1.7951 seconds for that. Let me double check that. That'd be sad to get that wrong. Okay, so I'm actually going to subtract that guy, right? Divided by 9.81. Okay, good enough. Okay, I'm just double checking that because it's all rests on that, right? If we get the wrong time, we're out of luck. Okay, so that goes across, and then we've got 1.7951. We get to do the exciting part where we calculate the horizontal position, right? S equals UT. So that's going to be this guy times this guy, right? So that equals 17.603 times 1.7951. Okay, so alpha A times 1.7951. I'm getting 31.599. And I'll just round that to 31.6 because it really wants to be rounded. Okay. Now it says write them in as proper component vectors, right? So let's just take the time to do that, right? My displacement is right here. Okay, all we got to do is just round that properly to the right sig figs, right? This is in the x direction and that's in the y direction. So my displacement or my position, right, is 31.6 meters over, right? I'm like that way, right? And that's in the x direction, right? Plus 30.0 meters in the y direction. So notice how, like, it's easy when they tell you a position because that is one of our answers, right? And then our velocity is right here. So what is our velocity at that point, right? Look at you guys. You guys are so smart. You're doing this. Okay, so I'm going to do my velocity at that point is 17.6 meters per second in the x direction and only 7.91 meters per second in the y direction, right? So it's actually the velocity. If you drew a picture of it, it'd be over a lot, up a little bit, right? Right, that would be the velocity. Sometimes these questions ask you to find the angle and the magnitude. I think you could do that. Make sure you draw it correctly if it asks you to do that, right? Make sure you have an arrow, that there's a tip of an arrow that I know that it's up and to the right. Make sure you label which angle you find and find the magnitude like that. But this one doesn't ask that, so we're done. Yeah? All right.